Here we have a problem on proportion. So three ratios are equal here. So this is continued proportion. Using this proportion, we need to find the value of the expression b minus c times x positive c minus a times y plus a minus b times z. So we have to find the value of this expression using the continued proportion here. Okay, so from the continued proportion, if I get the values of x, y and z, I can substitute for x, y and z into the expression and I can get the value of this expression. So now my aim is to get the value of x, y and z from the given continued proportion. Okay, so to get the values of x, y and z, what I am going to do is I am going to assume some value for each ratio. So in this proportion, all the three ratios are equal. Whatever value I consider for the first fraction or ratio, so the same value I should take for the second fraction and third fraction as well, because all of them are equal, because they are in proportion. So if I assume the value of the first fraction is 5, the value of the second fraction is also 5, the value of the third one is also 5, because all of them are equal. But I am not sure whether the value of each fraction is 5. But the value of the fraction is not given in the question, so we can assume any value for each fraction. So to make the problem easier, I assume the value of each fraction is 1. So all of them are equal. So if the value of the first fraction is 1, then the value of the second fraction is also 1 and the third fraction as well. So we get x divided by b plus c minus a is equal to 1, y divided by c plus a minus b is equal to 1, z divided by a plus b minus c is equal to 1. Okay, so if x divided by b plus c minus a is equal to 1, then the value of x is equal to b plus c minus a, the value of y is equal to c plus a minus b, the value of z is equal to a plus b minus c. Okay, now I got the values of x, y and z. I have to substitute the values b plus c minus a, c plus a minus b and a plus b minus c for x, y and z into the given expression. Okay, let's continue the problem on the next page. Okay, here I have substituted the values of x, y and z into the given expression. That is, for x I have substituted b plus c minus a, and for y I have substituted c plus a minus b, and for z I have substituted the value a plus b minus c. Okay, now what we need to do is we have to simplify this expression. Okay, let's simplify. Okay, before I am going to do simplification, what I am going to do is I am going to consider this b plus c as a separate part and c plus a as a separate part and a plus b a separate part, I mean the separate term. Okay, now what I need to do is I have to substitute this b minus c to the two terms b plus c and negative a. So when I do such substitution, we get b minus c times b plus c. So this is in the form of a plus b times a minus b. So we know the identity in algebra. So the product of sum of two terms and difference of two terms is equal to a square minus b square. That is the formula, the algebraic identity. A square minus b square is equal to a plus b times a minus b. So whenever we have such two terms a plus b times a minus b, instead of that we can write a square minus b square. So the same thing I am going to apply here. Here we have b minus c times b plus c. So for these for the product of these two terms, what we can write is b square minus c square, and b minus c times negative a will be negative a times b minus c. Okay, the same thing we can do for c minus a times c plus a, because I am going to distribute this one to c plus a and also negative b. When I multiply c minus a and c plus a, it will be c square minus a square. When I multiply this one by minus b, it will be minus b times c minus a. Okay, now I am going to multiply a minus b and a plus b. It will be a square minus b square. When I multiply this a minus b and minus c, it will be minus c times a minus b. Okay, so here plus b square minus b square can be cancelled, and minus c square plus c square can be cancelled out, and minus a square plus a square can be cancelled out. So we get minus a times b minus c minus b times c minus a minus c times a minus b. Okay, now let's distribute this negative a to b and negative c. When I do so, I'll be getting minus ab plus ac minus bc plus ab minus ac here. When I multiply this minus c and a minus ac, minus c times minus b will be plus bc. Okay, so this minus ab plus ab can be cancelled out, and plus ab ac minus ac can be cancelled out, minus bc plus bc can be cancelled. So finally we get 0. So the value of the given expression b minus c times x plus c minus a times y plus a minus b times z is 0.